Okay. First, we're going to start this. Everybody in the front row, I want you to all say hi to my mom because she needs a picture. Everybody ready? 3, 2, 1. There we go. Thank you. All right, mom's going to be happy. All right, my name is David Henner. I'm going to be talking about performance today. And a lot of people have asked me in the last couple of days, well, is this tech talk more geared towards junior people or more senior people? I've been telling people like it's probably more junior. But now that I think about it, I've seen a lot of your senior code out there too. And you might know what I am going to present, but you don't probably do what I present. So it might be a reminder for those senior people. But, oh, I need the clicker. And so when I started this talk also, I wanted to show that my face was the same size as Aaron's. And that ear is the same, by the way. But and I wanted to start with a whole bunch of little jokes. But then I realized, oh, I don't have 45 minutes to talk. I have 30 minutes to talk. Oh, shit. No, I'm not going to actually want to get kicked off stage because I think somebody would come up here and maybe, well, tackle my ass. Anyways, so I'm going to start by giving you a little history of Zendesk. Zendesk has been around about 15 years or so. We've had the first 12 years almost no dedicated performance teams actually working on the code. So you can imagine there's a lot of low-hanging fruit. And one of the things I need to talk about Zendesk is our endpoints aren't what, I'm guessing they're dirty like some of yours also, where our RESTful endpoints aren't really RESTful. And by that, for example, for our code base, we have an includes user in the ticketing endpoint, or it includes comments. So our actual endpoint will change the response depending on what the user asks for. So it's technically not a RESTful response. There's many different responses that you might get depending on what the includes are. That's going to become really important at the end of the talk because all of a sudden we came up with ways of caching that craziness at the end. Anything else? Yeah, and we've diverged a lot from Ruby on Rails, so upgrading is a pain. But here's the work that my team's been doing. This is just 3 people, and this is P99 data, which means that's the worst customer, or the customers, their biggest customers. And you can see all these trends. You can see when we released code, every one of these big staggering code changes are actually making a huge difference on our infrastructure costs. Don't believe I'm allowed to tell you how much our infrastructure costs was benefited, but think of it more in the tens of millions as opposed to 50,000 or whatever not. So we saved 3 people, and with the help of the infrastructure team, we got huge benefits here. So you're asking yourself, how did we do it? Well, the first thing I actually have to bring up is sharding and archiving. If you're not familiar with that, that's something that we actually were implemented well before I got into Zendesk. But if you're not familiar with sharding or archiving, sharding is extremely important. What archiving? I was expecting it. You don't look like DHH. Anyways, so with, man, now I'm going to run over and he is going to tackle my ass. So archiving, a lot of people just, they always have a small app in the beginning and they're like, okay, I'm just going to keep all my data in the main data store, whatever that is, usually MySQL. And they never even think that this data really is stale after a certain amount of time. You should probably have an archiving strategy and in fact, like a complete removal strategy of data and bring that up when you start your applications because bringing it up later is harder. And basically be able to tell your customers, hey, we're not going to keep your data, let's say 5 years. And then for archiving for the Zendesk, after a ticket is closed, most people won't care about the ticket after a certain amount of time. So after a certain amount of time, we'll say, you know what, we're not going to keep that in the MySQL data store. We're going to put that, we do it in Dynamo, but whatever store you might want to put. And then that will save your application from having to make SQL queries on just a huge amount of data set. So how did we get here? We did not have a PM when we started this team just 3 years ago, which actually probably was for the better because we let the data lead us as opposed to let's have this grand project. And there's just so many little things you can do within your app to actually get your app to actually perform well. But the first thing you really need to do in that effort is add observability. At Zendesk, we use Datadog. I'm sure many of you actually use Datadog and probably are complaining about the cost. But so here's what a typical trace that we had before we started the team would look like. And we actually added a lot of little details in here. Any place that you see anything yellow below the purple is stuff that we added custom. But the problem with this data is it still left a lot of empty spaces. But to fill in all that data, it would just cost a lot of money because Datadog charges for the amount of the amount of traces you actually put in there. So we needed some flexibility. And I'll go into the flexibility that we added. And then essentially, these Datadog traces that we actually do add are work in progress. New features will come up. You need to add more traces. New areas that become slow in the application for some P99 customer, add more traces. So you never can say that you're done, but adding this observability was absolutely crucial to find the problems that we were doing. So how did we do that? Here's an example method. It's actually not a real method in our application, but you'd have a new ticket method, for example. And this is just the syntax I'm really showing you here, but the syntax is essentially you have a method called wrap debugging trace. You pass in new ticket, and new ticket is the method name. And then the second new ticket parameter is actually what you want to call it, that trace in Datadog. So you might not want the same trace name. And the last one's really just a color coding. We mostly use the same color coding for anything custom that we're doing, but you can add some color coding. So here's the syntax for the block notation that we have. And it's exactly what you see. It's just basically a block where you add the slow method in between. The problem with this method is that it clutters up your code. You don't want blocks all over your code. So the other way to actually add traces is better. But then let's actually dive more into the actual implementation of this. So here what we have is the block notation implementation. So what you do is the first couple lines there is a software switch. We call our software switch Arturos. None of you call your software switch Arturos. Anyways, essentially you see if you have the feature. If you have the feature, then essentially what you're doing here is wrapping a trace around your implementation. If you don't, then you just yield to the block and it just renders like normal and it's almost like the block is not even there. Likewise, for wrap debugging traces, which was the implementation that I showed, can I go fast? Yeah, right here. For wrap debugging traces, this is what we do. Essentially what we're doing is you redefine the method that you're actually wrapping the block around. So you have the same code that the block notation within this, and you redefine the method that you're trying to actually put traces in, and then you call that method within this block with this syntax here. So what you get before is traces that look somewhat like this, and I need a drink, it's my water. And which just gives you a good amount of data. But then after you get something like this, where you can dive right down into the actual problem. You can find the actual method that if you zoom into this, you'll see something like this, where all of a sudden you can go into merge ticket data in the model. That's an actual method in our implementation. And that purple thing on the bottom, we know that's a query. That query is happening each time you call that. Is it n+1? Do you want to cache that data? Is it an okay query that you expect? Well, now we could have ways to debug every query, know exactly where they're coming from, and know how to actually remove it. The other thing you have to know, as I said earlier, these traces are not free. This block on the bottom is not one trace. It's actually 5,000. It's just they're so damn close together, it looks like one. Now, ironically enough, the latency added to 5,000 extra traces with Datadog. Datadog's amazing. It does not actually give you much extra latency that is even noticeable. That being said, I've released code that I'm not so proud of that added 200,000 extra traces. It's only a little while. We only turned the software switch on for a little while. But that was code, a loop within a loop within a loop. I think they call that n cubed or something like that, where we got 15 seconds extra response times. And we turned it off quickly, but and it was easy to find a problem at that point because you're like, oh, shit. But yeah, don't do that. I'm going to move on to some testing that we do. One of the things I don't see in a lot of applications is testing for the number of queries. We have a very specific syntax at Zendesk, but there's a whole bunch of open source gems that you can actually test the number of queries that you have in your application. It's really important for things that you especially expect no queries from, but could have queries. And the syntax is something like this, where you have assert SQL queries, you pass in the number of SQL queries you want, and then you pass it to regex. It works really, really well, but we actually do this for memoization also. Put this in your memoization code. You say, hey, the first time I expect a query, the second time it better not have a query. And if somebody else changes your code like 10 years from now or something like that, they're going to actually have a failing test. And yes, that does happen. And I'm gonna keep moving, cycling through a whole bunch of topics. This is another one where a lot of you go, oh, I wanna do some feature that has some dramatic differences in Datadog so I can show my boss what I did for work. Yeah, that's nice, but you know what? There's endpoints that we have in our application that gets 87 billion, and I think it's more like 100 and something billion requests per year. Well, if you multiply 87 billion times 1 millisecond, you're saving 1,000 days worth of SQL on your machines. Sure, it's not going to look really great to your boss because he's going to be like 1 millisecond, really? But to your infrastructure team, they're going to say, God bless you. Here's something that we do at Zendesk that I don't think most people have seen before. I don't know, but anyways, we have something, our account object is actually what I would call a God object. You can call it a singleton, but we don't follow the exact singleton pattern, so I call it a God object because it is God. What that means is if you call for the account any place in the Zendesk, whether it's user.account, ticket.account, current account in your controllers, wherever you call it, the object is the exact same object. It's not just account.id is the same. It's the same object ID, which allows you to leverage that and take that object, and now you can use that object anywhere and memoize on top of that object instead of the object that you're getting from someplace else, that there's a code implementation way over here, and then there's a code implementation way over here. But you can't figure out how to actually memoize the two because they're completely different pieces of the code. Anyways, I'm going to be going into this quite a bit. If you're not familiar with memorizations like this, the syntax looks like this. If you need help on that, you're probably totally confused, so I hope that you understand how to memorize very simply. Here is an implementation of, that we didn't do any type of memoization where we just loop through a whole bunch of audits. We'd call audit.author, and then author.user emails. Most of the time, the author was the same author. Not the same object ID, but the same exact author. We called user emails on it, and we'd get anywhere from 1 to 3 queries every time we called this, even though it was the same damn author every time. Our implementation is a lot different than this, but this is the condensed version. Well, if you actually leverage the fact that you have that account object that is the same account, and you've put the user emails method on the account object and just pass in the user, well, now all of a sudden you can memoize that on the account. And if you actually have to use user emails any place in your request cycle, you actually get a memoized result all after the first time. Changing topics again. A lot of people in Ruby on Rails, they're always getting back arrays from their data sets. Makes sense? Great. But the problem is, sometimes an array is not the right thing to use for what you're doing. And yes, in this case, there's only 3 things in the array. But let's pretend this is not 3 objects in your array. Let's pretend there's 20,000. Then you do some calculation, and then you call unique. Well, unique is not a free method when you have a huge array. So this is going to create some time in certain cases. In fact, in ours, it did cause, let's say, 100 milliseconds of time. I don't know what it caused. But anyways, if you change this to go create a set and then do that same sum calculation, but now actually keep on adding to the set, you're guaranteed uniqueness at the end of that. This set, by definition, is going to be unique. So now, instead of actually calling the unique method and spending 100 milliseconds on that, you're just iterating through, and you get unique values, and you don't have to even call unique at all. Likewise, with leveraging a hash, I think this is more obvious, but it's something that I just want to go through. Is basically an array. You can use a hash and instead just look for the key. You have an O of n one operation, or L of 1 operation to actually constant time to look up for the 3. And I just have nil here, but you could actually have some calculation, 3 equals something. And your operation is just going to be so much faster because you're leveraging a hash. I'm adding this also, flat map versus flatten. It's literally because every application I've ever opened up uses map.flatten all over the place when you could use flat map. I'm not going to go into the differences of the two, but you do have to know that there is differences, but every implementation of map.flatten that I've ever seen can be replaced with flat map. I've never seen a case where it hasn't, at least in my applications. More water. So at Zendesk, anybody knows what Zendesk is, we get a ton of emails coming in for customer tickets. In those emails, that data is, if you've ever looked at emails, it can be shit. And you get in the emails, and there's one customer. Whoever did this is just stupid. But anyways, one customer, they had an email signature. And at the end of their email signature was at least 36,000 empty spaces. And our regexes, for whatever reason, were run on the outbound. And it made sense to run the regexes on the outbound. The problem is our regexes were extremely slow with spaces. And, well, this customer was complaining, why am I getting bad, slow responses? Well, Jesus Christ, what? Anyways, this is not our implementation exactly, because we had to take care of tabs, we had to take care of new characters, we had to take care of returns, but essentially, you can just run a simple sanitizer to some degree, whatever your data you're trying to sanitize. Run it on the inbound of the actual data coming in rather than the outbound, and it saves time. Give a pluck. So let's picture you have a form. That form has a whole bunch of fields, and some of those fields are drop-down fields. And all those drop-down fields have options. So let's say, so they all have options. Typically, a drop-down field should have, let's say, 100 or less in your options. But we give our customers a tool. And when you give a customer a tool, some customers want to shoot themselves in the foot. And yes, we do have limits in this, but at the end of the day, some people go way over the limits. And I'm talking like 20,000 fields in your actual drop-downs. Our problem is, originally when we got the data from the options, we grabbed the data and we just instantiated 20,000 active record objects. What can go wrong? Well, a lot. And essentially, what we did to change this is we changed this and we actually used a pluck. This isn't the exact implementation because it would be too long for the field. But what we did is got that data in pluck, convert it to a hash. Well, when you convert it to a hash, that's just so much faster than instantiating 20,000 active record objects. And then the presenter before, it looked like this. It was very readable. It was active record. After, it looks like this. It's not as readable, but it's pretty damn readable. And if you're going to save, let's say, 500 milliseconds on some of the responses, it's hella worth it. One of the things you're probably not asking, but when I gave this talk internally, they were asking, what is this ticket field store? So the ticket field store in our application, well, it looks like just like an object that we store ticket fields in. Well, one of the things you got to know is Zendesk, our ticket request cycle. You go in and let's say you have in the beginning some validations. In the middle, you do something that we call triggers. And in the end, you have a presenter. Well, each one of them needs a different subset of ticket fields. The beginning, you need maybe all the ticket fields. In the middle, you need a subset of ticket fields. In the end, you might need all of them again or some combination of the above. Well, what we did is, hey, let's create a ticket store. We know the account object is this God object that I was talking about. We can memorize it, and we can reuse this data throughout the request cycle. So what you have in the beginning is that you're using one subset of the data, another subset of the data, another subset of the data, and at the end of the day, like, you're making one query for all that data instead of 1, 2, 3, instantiating those objects, because that ain't free either, and you're saving a hell of a lot of time. And if you want to take that one step further, you can actually leverage Active Support Memory Store. I wish I actually had time to go with the implementation of this, but Active Support Memory Store, what you can do is now, when you make that initial call, you actually check to see if you cached this up already. Because we never change, or very rarely change ticket fields, we can actually store that in memory. And if you store that from memory, instead of actually making a call in the beginning, in the middle, and the end, we never make a call. We just get it from memory every time we actually make the request. No requests throughout the whole life cycle for many of our implementations of ticket fields. That is technically the code. I don't have time to go through that, and it wouldn't make sense unless I actually added a heck of a lot more code. If it was a 45-minute talk, though. Anybody in a tap on? Anyways, I'm going to move on to max age. You may or may not be familiar with max age, but the syntax in the Ruby code is something like this, where you say expires in 60 seconds. If you don't know what this is really important, because I'm going to go back here. This is the amount of traffic we reduced after implementing max age. And what max age does is, if your browser makes a request, let's say it requests the tickets, and then you send back the tickets, and expires in 60 seconds is set in Rails. When you make the call the second time, your browser stops the call and says, hey, yo, you asked for this 60 seconds, it'll be within 60 seconds. I'm just going to give you the same data back. So the fastest traffic you can ever have in your application is the traffic that never hits your application. So that was a big win. Last, and oh my God, I went so friggin' fast. Did you add time? Either that or I'm just talking fast. But anyways, stale. Stale in Rails is amazing. If you don't know what it is, well, I guess I have time to explain it. But anyways, stale, unfortunately, because of the reasons what I was talking before, does not work on our application. Because what happens is, stale is supposed to see if the e tag that's sent in is stale, and if it is, if you're using the same e tag that is not stale, you don't render. What you do is Active Record takes, or the implementation takes brands and says, oh, you know what? This is not stale data, so it doesn't render that. It goes back to the middleware and then converts. Man, I'm saying this wrong. Anyways, at the end of the day, in the middleware, what happens is the 200 that response returned here is changed to a 304. And what 304 means is no content is sent back. So you didn't need to actually render anything to the customer, which saves you a lot of time. Unfortunately, so that does not work at Zendesk. I kind of gave a little bit of a history, but anyways, so the history of Zendesk. In the beginning, or essentially this is what middleware looks like and your controller looks like. Typically, the stale method is called here, which means all that time at the end does not have to be actually used. You return really fast from your responses. Unfortunately, at Zendesk, we have to calculate the e tag value at the very end of the response, because depending on the parameters that were passed in, we have no idea what the actual output will be. So we're looking at the output and seeing what the e tag value would be. But we spent all this time, yeah, sure, you get less traffic in the water. You get less traffic over the wire going back to your customers, but you're not taking the advantage of the reduced time you can do here. So what we do, oh yeah, and by the way, this is not because of complete mistakes. There's a lot of times your product managers will go in and say, hey, listen, I need this, and I need it tomorrow because we're going to lose a customer or something like that. And by the way, when Zendesk began, there was no such thing. Oh, there might have been such thing as the e-tags, but it wasn't in Rails. So we had to create our own implementation well before Rails actually started. We didn't create it correctly, but hey, it worked, and it was a heck of a lot better than it was there before. So, wow. I just described that. By the way, I actually sent these to this, anyways, good. So the real solution here is for us to actually go in and start using Rails the right way. Unfortunately, that is hard. It takes years. Our customers are used to our APIs the way they are today. We can't just go in there and say, hey, here's a new API. You can't use the thing that you used 15 years. Breaking changes are dreadfully hard when you have 250,000 customers. So what we did is we cached that e-tag at the very end, right here. We cached that value. And then we took that value and we saved it in cache. And then when we had a new request, we would take a look at the cached e-tags that we had actually, and by the way, we have phenomenal cache busting at Zendesk. It's a very personal thing to every customer, or to every implementation, so your implementation of how you cache bust is going to be very personal to you, but we have phenomenal cache busting. So anyways, we check the e-tags that came in, and we compare it to the e-tag that's coming in from the request. If it matches, we know right at the beginning of the life cycle that we don't have to look at the presenter. All of the data is fresh, or is good, or not stale. So what we do is we set the headers to the tag that's appropriate, and then we turn 304 not modified. And as I was saying, in Rails, it's actually the middleware that kind of takes care of switching from 200 to 304, and then sending no content back. But in our implementation, we kind of do it much more at the controller level. And again, this is my last slide, kind of, where your caching strategy is very important. You got to talk to probably everybody on your team, get a good caching strategy, and you're going to be able to leverage a lot of just great work and make your caching strategy easy. It's a whole new talk, and probably many talks on how to create a good caching strategy, unfortunately. I'm supposed to stop here, but I do have extra 5 minutes. And I had planned to make this a joke slide where somebody was going to come and tackle me off the stage, but I guess I can actually talk about this also. I don't know if I have time for all of these, but when you cache, a lot of times you cache on a single object. And you go, okay, I cached that. And then you're like, hey, I cached. I did a really great job. I cached this user, for example, or something like that. But then in your implementation, you're in the index action, and you call your cache again and again and again. And you make 100 calls to cache. Well, guess what? If you make 100 calls to your cache, you're actually getting you basically have an n+1, but it's not in MySQL. It's now in your caching layer. But leveraging read multi, you can actually get all that cache at one time. So this is really important. If you're actually looking at your Datadog slides or however you monitor your stuff, you will save a lot of time by grabbing data using read multi instead of however else you're doing it. And the last thing, and since I do have time, I'll talk about forcing indexes. Damn, this was my code. I was wishing I wasn't supposed to actually present this. I went a little fast. Anyways, let's say 7 years ago, there was code in our there's code that we implemented, and we forced indexes because at the time it made sense. Well, as time goes on, new features are added. You go to Aurora 2 to Aurora 3, or MySQL 5 to 8, I think that it was. But anyways, you change a lot of things in your application. Well, you got to keep on going back to your places that you force the indexes, because sometimes they don't make sense. The biggest gain that I had in the past year was removing a force index on our ticketing endpoints. It was so sad because I implemented the code to force the code, and then 7 years ago, I'm like, who the, oh, sorry. Anyways, does anybody want to tackle me off screen? That's it?